Okay, so let's finish up part C. What we need to do here is to test um, the convergence at the endpoints. So we have x equals -1. So what we're going to do is take our general term, the a sub n term above, and we're going to substitute x is equal to -1 into that. And when we do that, we're going to get -1 minus 2, which is 3 to the 2n, -3 to the 2n. But because that's positive, that will come out to be 3 to the 2n. And so that leaves us the series 1 over 2n. And we know this is going to diverge because this is 1/2 of the divergent harmonic series. And if 1/2 of infinity is still infinity. If you wanted to test that out, we would use a limit comparison test. And so that would look something like 1 a sub n over b sub n, and our b sub n would be 1 over n, which we happen to know diverges. So simplifying that, we're going to get 1 over 2n times the reciprocal of the denominator, which is n over 1, and that ends up being 1/2. And the limit comparison test tells us that whenever that limit, as n goes to infinity, of the function or the series we're trying to test over the series we know diverges. If it gives you a real number for the limit, then they both diverge. If we knew that the bottom function converged and it gave you a real number here, then we would know that the top would also converge. And so the LCT, the limit comparison test, tells us that when the limit as n goes to infinity of a sub n over b sub n is a real number, both converge or both diverge. All right, we're going to go on to test the other endpoint, which is 5. And at x equals 5, we now have 3 to the 2n. And we don't have to worry about it being positive. It already is positive. And sorry, I can see I made a mistake in the at x equals -1. That should be 3 to the 2n over 3 to the 2n. And that's why the ratio comes out to be 1 over 2n. You can tell that above, that we have 3 to the 2n there, not 3 to the n. And so here we're going to have the same exact situation. And we have 3 to the 2n over 3 to the 2n times 2n. And again, and it converges by the same exact limit comparison test. So neither of the endpoints are included here. However, if you still gave the answer without considering the endpoints and without finding that the endpoints specifically diverge, you would have lost 2 points there. And these were easy tests to do, so 2 points is 2 points. Along with the other parts of this, this was not a very difficult problem to work out. So we're finished with this.